Well,
nothing's showing up. Yeah.
Okay.
it's good that
Are
you've
you
got the
using
matrix
a
view.
MacBook Air, right? Is that right?
It's a MacBook Pro. It's a few years old. I'm using 14.6 Mojave. I think that's fairly up to date.
That is really strange.
Okay.
I will try to figure it out why it's not working.
So I had a look at your YouTube session from last week, and I've had a quick look through the paper. I can send you a bit more detailed feedback. I'd say it looks really impressive. I'm very impressed. It's a very neat interface, and I can see it can be very useful, and I think it's got sort of clinical and research benefits really. A few things, some of them are small. So drugs there are different names for the same drug, which you have to be careful of.
Yep.
So for example, Keppra is exactly the same thing as levetiracetam, and Epilin is exactly the same as sodium valproate. They just every drug has a generic sort of chemical name, and then you get a trade name based on the manufacturer. So going through, looking at some of your discussions you had last week on the YouTube, you're saying it was a bit odd that this person only, there are lots for sodium valproate, but there's only 1 or 2 Epilin. It's the same thing. So maybe, we can give you a list. Just someone looking through that who knew a bit about epilepsy, something that would strike them.
Sure.
And then can you just explain the drug chain view to me? That's basically showing across sort of horizontally, that's one single letter, isn't it?
Since you didn't get to see the software in action, I will show you from here.
Okay.
So the drug chain view, just one moment.
But yes, you're right. Each chain does represent one letter.
Okay.
That's right. So each line.
And so you're seeing spatially, so where in the letter the term is, as well as how often it comes up then. Am I right? That's what it's showing.
It's showing the order in which the drugs appear in the letter.
Yeah.
It doesn't show exactly where, it just shows the relative order.
Okay.
Yeah.
Okay.
Yeah. The graph view shows the position, actually.
Yeah. Okay.
So that's when you click on a matrix cell, it generates the drug chain view.
Yeah. So if you just hold it there now, so that, for example, is showing the 6 letters where you've got pregabalin and lamotrigine in, or pregabalin and. Yeah.
It depends on the colors. So the yellow represents lamotrigine in this case. The color map is here, right? It's not visible because I zoomed in. So if you click on, let's say the first matrix cell is clobazam and sodium valproate. So it highlights the blocks with those 2 drugs.
So let me see now. So clobazam.
Clobazam is really light here.
Okay.
Where's clobazam? Where's clobazam? That's a good question.
There. Okay.
Yeah.
Right. So in that letter, it's showing the relative positions of them, not absolute. Okay.
No. Well, you can see it's absolute position of the drug sequence.
Okay.
So the clobazam, sodium valproate followed by clobazam and followed by sodium valproate again.
I see. So in that view, the colors are just different drugs.
Yes, they are just different drugs by the list supplied by you.
Okay. And I suppose the length of the horizontal rows then will give you an idea of how many drug names are mentioned in that letter.
Yes.
And then when you go through the query history, it sort of you keep on adding a search
Yep.
term unless you untick those blue boxes on the
Yes.
left. Is that right?
Yes. Yes.
So what you're showing is all those queries there.
Yes.
Right. Okay.
Different queries are connected by an operator or.
Yeah.
So it's the first query or, second query or, third query.
And just to clear my mind, so you're taking as an input here our JSON files, which are sort of the output of the NLP thing, isn't it?
Not 100% at this stage, but that can be easily, modified. Because for now you can take JSON and text file, but since JSON format, each JSON file essentially they have this own format structure. So the one output from Metgate has its own format.
Yeah.
So all I have to do is to adapt to that format.
Because the advantage of the JSON file over the text file is that there's some things like negation and stuff in there, because as you said, that not every mention of the drug will be an instance where that person is actually taking the drug. It may have been said that they stopped clobazam 2 years ago, or we had a discussion about phenytoin today. That type of thing. Yeah.
For instance, this is one letter 27.
Yeah.
So this one has all the information I need to generate my visualizations.
Yeah.
So it has line number.
Yeah.
And the value and everything. So essentially it's my own structure, but all I have to do is to adapt Metgate's structure to accept that format, then it will work the same way.
Okay.
Because in Metgate we have like annotation, attribute.
Okay. So I think where this would be useful is on different levels, isn't it? So you'd be wanting to maybe look at a whole host of documents for a single person.
Mm-hmm. Yep.
And you probably want some kind of timeline in there, wouldn't you? As well as this, which you might want to think about. Sort of, say it's a person with a nasty epilepsy, and they've been 10 years back and forth.
Mm-hmm.
And what shall we do next? What change will we make next? You'll want to correlate the drug combinations with sort of good periods of seizure control or bad periods of seizure control. So that might be handy. And then as well as looking at per person, you'd probably want to look at your own sort of cohort, all the patients I look after. There's been some, you want to audit your work. Are you up to standard? Are you forgetting that you shouldn't really prescribe medicine, or how many pregnant people have you got, and then you probably want to look at your whole local population to try and give you an informed choice of what's going on, like what this is doing. And I can straight away see that lamotrigine and levetiracetam are very common combinations, which is what you'd expect, And then perhaps you'd want to say, for a particular person you're unsure what to do, can you harness all the data at your fingertips to make an informed choice? So someone's tried carbamazepine, it hasn't worked, and they're a female and they're 30 years old. Can you search all females who are 30 years old to look at their drug combinations to perhaps inform your next choice? Because I guess what you want to do is something visually, which is hard to do with just a text search thing, isn't it?
Well, we can search by age. We can do a search by age, or in a sorting by age. And we can also sort by gender, so we can pick out just the females, for example. Sort them by age, and then look at similar females in the same age bracket.
So that's fantastic, and I suppose we'll have sort of epilepsy type and seizure type as well, and that would be something to think about in the future. And then as well as wanting to know what these people are taking, you want to know if it's any good or not, because it may be that lamotrigine and levetiracetam is a very popular combination, but you're not quite sure if it's popular for the right reasons. It might be the easiest one to give, not the best one to give.
Yeah.
It's really good. I'm very impressed with it.
Owen, do you consult? I got a copy of these books that I unfortunately I don't have them with me. They're in my office, but they're books. They're very thick, and they're about drugs, like drugs used in Britain by doctors. And so it's like an encyclopedia of drugs, like when they're recommended and all the side effects and things like that.
So the one to use is BNF, British National.
Yes, that's the one.
I think that most of that's online now.
I see.
I'm not. Yeah, I wonder if there's a way these days link in with it.
Do you look at those?
I do look at the BNF, and most doctors would. It's your kind of legal backup.
Okay.
So if you want to prescribe something, you want to check that you're within the BNF kind of guidelines. Or if I was looking for side effects, there's so many side effects for drugs, I might check the BNF. And what's really good is its interactions. Because that's another thing potentially to think. What's really neat here, you're instantly seeing combinations. Interactions are quite a big thing in some of these epilepsy drugs. Some of them, the way they work biologically, they increase or decrease the levels of other drugs. For example, if someone's on sodium valproate and you want to prescribe lamotrigine, you would prescribe it at half the dose you would if they weren't on sodium valproate. For example. So there are lots of interactions which the BNF's quite good at telling you on.
Yeah, I'm looking at it at the online version now.
I was just thinking, like, for a single drug, there was a long list of side effects for some of them and interactions, and I just thought, how is it possible to navigate this side effects and interaction space with all of these drugs? Like, it doesn't even seem to be possible.
Well, that's a very good question, and it is impossible. If you talk about every side effect, every interaction, you wouldn't prescribe anything. But you just have to, take a little bit of risk sometimes. And also remember that this information is derived from people reporting they've got a side effect. So, they take a new drug, and they say they feel tired, and then that gets fed back to the BNF, and then the next edition of the BNF, they say, well, perampanel causes tiredness, so it's been associated with tiredness. But there's 101 different reasons why someone might be tired.
Yes.
For example. So there's that, but there's normally some severe things that you can't ignore. So it's a matter of filtering out the noise. There's lots of noise in this BNF, for example, and there's lots of noise in real life as well. If somebody in clinic says, "Oh, I think this drug is giving me this side effect," sometimes it's very difficult to be sure because there's lots of other things that can cause the symptoms.
Yeah. I suppose there might be some placebo effects in there as well.
There's placebo and there's this nocebo effect, which is very interesting. So if you tell someone that a drug might give them a side effect, they'll get that side effect.
Yes.
So there's a very interesting New England Journal of Medicine paper recently about statins, and they told people, statins can give muscle aches, and they give them placebos, and everyone had muscle aches.
Yes, I just read about this nocebo effect in a book recently, a very good book. I think it's this book on my desk. It's called Humankind, and it describes the nocebo effect. I had never heard about that until this year, actually. Yeah, it's very interesting.
And then, yeah, it's something we're quite familiar with, but hasn't really been properly described. So we know that there's a group of people, if you tell someone the drug's going to have a side effect, they will have that side effect. It's through no fault of their own, I guess. It's just how the sort of software in their brain is working. But I guess you could use this software to try and help filter out noise and what's a real side effect, because the pharmacology gets complicated very quickly. And epilepsy causes a lot of issues. What's the epilepsy? What's the drugs? What's something else? Other medical problems. So that's something to think about.
Yeah.
And so it's really good to tell you the common combinations there, that matrix, isn't it? But I guess that moving forward, you need to know some other information, like are those combinations associated with good or worse outcomes, type of thing.
Yeah.
The other slight thing for the paper and really the YouTube thing, so these letters are anonymized and we've changed details. However, theoretically, someone could look at the text and potentially say, there's no one else with a letter like that. That must be me. What's my letter doing there? So with the paper, any views of whole letters, just give the letter to me and I can change a few details or whatever, just so that we put another layer of just to make sure that that's changed again, really, just to be careful, ultra careful.
Sure.
We can also blur the text if we show a letter.
Yeah,
I think I can blur the text, just leaving the drug names, because all I need is actually the drug names.
That's right. That would be fine. It's highly theoretical, and I'm sure it won't happen, but it's possible, isn't it? I suppose that's the thing that you should bear in mind. So I am working on creating just purely synthetic letters. And sort of rewriting letters, but based on real text. So if I write a proper letter, then I'll rewrite another one in a similar style, but completely synthetic. And then you can do anything with those then.
I'm curious, do you have like a template saved on your computer that you can just fill in the patient name and condition and everything?
It's a good point. So this is the thing, isn't it? At the moment, every clinician has their slightly different style. And they'll do things slightly different, and you normally be able to spot a clinician style, the stuff they put at the top of the letter, the stuff they put at the bottom of the letter, but most of it doesn't follow a strict template, although some people are starting to do that now. I think there's two things that people are reluctant to change, and people are like their autonomy. So doctors quite like their autonomy to do things they like in their own way, and they don't really like to be told too much about structure. It doesn't bother me. It doesn't bother me, and I try and make my letters a bit structured. What else was I going to say? Yeah, sorry, I've been talking a lot.
No, it's fine. It's fine. Yeah, that's what we want, actually.
Okay.
If you had the software working and you wanted to do something, we can try it with Wang right now. Some exploration.
No, and I looked at the YouTube thing, so it looked great, and I just wanted to fiddle around myself, really, just to try and understand a bit more.
I will try to fix the online version.
And so the other
thing, why it's not working at the moment.
Okay, it might be something silly that I'm doing.
No, it doesn't work on my side as well.
Okay.
Or something.
Okay. So the other thing is that I was planning to do an MRC grant around NLP, and I wondered if you'd be interested in being a sort of a partner on that grant. The basic gist of it would be that we run our NLP stuff on as many letters as we can, millions of letters, and for the visualization side, we could work with you to develop LetterVis on this bigger scale, really. That's going to be in the deadline is January, I think. So I'm just in a bit of putting it together. We could potentially add some costs in for you to, if you wanted, etc., and work through that. I don't know if that's something you'd be interested in.
Yeah, I think that would be good. We are doing something similar, actually.
Okay.
We have an EPSRC bid that is due, I think, at the first week of February.
Okay.
And we're trying to get Swansea University School of Medicine as a participant in the project. It's not only Swansea University School of Medicine, but as many participants as possible, basically.
Okay.
Yeah. So I think there's a lot of overlap.
Okay.
It also has an NLP component to it. We call it visible NLP, so we're trying to develop methods that show a graphical representation of the NLP process that shows like each step in a graphical interface and what's happening in the different phases of the NLP pipeline. That's part of the project. Yeah.
Yeah, it's a good idea, isn't it? Because I suppose you could use some visualization techniques to work out where you're going wrong with your NLP. What do you think, Arron? Things like seizure frequency, which are really difficult. Could you sort of visualize the distance you're away from the ground truth? Would that help the things that you wouldn't have thought about otherwise?
I don't know. That'd be really interesting, because we take two approaches at the moment. Obviously, Owen, when we're using human rules, and we know that they're not flexible enough to capture everything, and we're also using machine learning. And in terms of, if you could sort of visualize the error, like kind of summarize the error, it'd be easy to incorporate those into human rules. We're missing these kinds of examples. So that would be interesting. I don't know how you would visualize that.
Yeah.
No, I don't know either, actually, but because that is the tricky bit, isn't it? Is knowing how to improve the accuracy of your NLP, really.
Yes.
Just checking volume at it is one thing.
And just understanding the decisions that are hidden inside the algorithms that you don't normally get to see.
I don't know whether it's just simple things like, we tend to get it wrong when the seizure frequency or the prescription is embedded in a very long sentence, or potentially across multiple sentences, just maybe even a word cloud where we get it wrong. What's the word cloud in the sentence span, or sentence either side? Could be some problematic words in there, double negation. I don't know how to visualize it.
Well, that's our job. Our job is to figure that out. Yeah.
I know machine learning algorithms that you can get them to explain why it thinks an example is correct. It works better in computer vision. So, with chest x-rays, you can actually get the machine learning process to highlight a part of the image that it thinks is important. And it can also do the same with spitting out letters and sequence of words, in NLP. I don't know, if you're interested, Henry, and the rest of your viewers. something called a line explainer in Python.
Mm-hmm.
As in the fruit line explainer.
Mm-hmm.
I don't know, maybe that could help in that area.
Mm-hmm. Good.
Yeah. That'd be really interesting, because that's the thing we bash our heads about, is where we're going wrong.
Mm-hmm.
We get to this, we plateau the seizure frequency. We've got to about, I don't know, 70% accuracy overall, and we just can't get any better than that.
Mm-hmm.
Yeah.
Mm-hmm.
So,
Yeah, I suppose something like this would be good for potentially getting a training set with it. Selecting, because that's the other issue, is getting a balanced training set with all the right features in it.
Mm-hmm.
I suppose you're looking at, you could do that, just a search, I guess, but I wonder if you visualizing. I wonder if you could use this to, the other thing is visualize cohorts by clinicians and outcomes as well. Or geography is the other thing, that we're really worried that, there's quite a geographical postcode lottery in outcomes.
Yes. Yes.
Yes.
And you see a map of Wales, and you know where the epilepsy specialist nurses are, for example, and you know where some people in mid Wales will don't get enough contact. Geo, some kind of map, because equality of access to services is a big thing. And the other thing I'm worried about, thinking of COVID and topically now, is that we rely on lots of people to get in touch with us now and to let us know there are problems with their illnesses. But if we could pick up patterns where we need to be proactive. So you could look at, people haven't been seen a while. The gap between letters is very big. And either that's because they got no problem, or they died, or, they got problems and they're not getting in touch.
Mm-hmm.
And it's that group we'd really want to highlight, really. I don't know, I'm just thinking off the, just thinking out loud.
Yeah, no, that's fine. That's fine. So you
but
guys...
I think outcomes is the big thing, isn't it? We like where there's drugs, you know where the popular combinations are, but then you want to really know, are they any good? Are they popular because they're good, or because are they popular because that's what everyone does? Or are they popular because it's the easiest thing to do, not necessarily the best thing to do?
Do you have some NLP strategy for outcomes?
yeah, so as I said, we're trying to get seizure frequency in various ways, and we know what drugs they're on, the full prescription. So the idea is that we could figure out that if someone's seizure frequency while they're on a certain drug is this, and then they change to another drug or combination, and maybe you could spot their seizure frequency decreases. So that's something that we've always wanted to do from the start. It's quite difficult, and at this point we need more letters. Because we're talking about machine learning now to augment our results, but we need thousands of letters, and currently the health board are sort of digging their heels a bit. So that's definitely.
We are close, aren't we? I think
Yeah, we are. I think once we're there, and that's the thing. Once we're there as well, we could invite you guys up, to potentially have access to those letters, so we could work in tandem then.
Yeah, I think because a visual element, people respond so much to this visual element. That screen grab you've got in the first figure, that's really impactful. I think that gets people drawn in. We can give tables of F1 scores and precision and recall, but I think it's really quite impactful and will help people get on board, I think.
Yes. Data is more useful if you can see it, right?
Yeah, I think so, yeah.
So you guys know we have a deadline coming up, right?
Which is the end of next week, is it? The 4th?
That's right, that's right.
So, yeah, I will look through the paper in detail in the next couple of days and get back to you. I think in terms of the same name for the different name for the same drug, do you think you'd change that on the paper, or is it too late?
No, it's not too late. I think we can change it, can we?
Yes, I think that should be possible, yeah.
Just something that is a bit obvious if you know it, really.
Yes, I don't see why we can't change that.
Sorry, that might have been our fault for not explaining that to you, but...
No, that's fine,
So the BNF, that's the other useful thing about the BNF, actually. It'll give you all the trade names in there, so you can search for one name, and it'll come up. In the preparations section at the end, it'll give you the other names, but for example, lamotrigine's also called lamictal, but if you search for lamictal in the BNF, it'll point you to lamotrigine.
Okay.
Tricky business.
Yeah, I always try and use generic names, and this is how drug companies are very clever. They make the trade names easier to say than the generic names. And if you write on a prescription the trade name, then the pharmacist has to prescribe that company's drug. So that's the trick. So, Keppra is easier to say than levetiracetam. So people who are just getting the habit of saying Keppra, they'll write it on the prescription, and the pharmacist has to prescribe, UCB's preparation of levetiracetam instead of the cheap generic one.
Smart.
Okay.
So I always say, well, no, I refuse to do that. I'm going to stick with the long one.
You know, a drop down, Owen, where you type in Keppra and it says choose the cheap one here instead.
Yeah, it should be. Yeah.
So you guys will be able to maybe put together a few paragraphs of feedback, like why you think it's useful, how you think it might be useful, and stuff like that.
Of course,
So,
and you sent me a template, isn't it? And basically the things I've said today, you can say again, and I'll have a think, and if anything else comes up, I'll add that in.
Great. Yeah, that would be great. And of course, we're hoping you'll be co-authors on the paper as well.
Yeah, of course, if that's okay with you. That's obviously good for us, yeah.
And maybe that can help with your bid process as well.
Yeah, obviously, they'd be impressed with your work, I'm sure.
Do you think the MRC is sort of interested in visualization?
So it's a tough call, I think. It's a tough grant to get, but there does seem to be machine learning, NLP, that kind of stuff in health is quite trendy. And as I say, I think people would respond to looking at a screen grab and things like that. I suppose the question is, what advantages, concrete advantages you're getting over doing a text search and getting the answers there. But I think it's spotting patterns that you wouldn't see otherwise, isn't it? That's the main thing, which we do all the time. Spotting outliers, that's really good. You might not have thought to think of looking at people who are on the tigabean and pregabalin, which is a very strange combination. I never thought of searching for that, but if I could see in your matrix that's when I think, I'm definitely going to look at that patient. Especially, I suppose, as we are moving into pushing the onus back onto the patient to get in touch with us now. That's the trend. Traditionally we see everyone 6 months till they die. But then your clinics get very clogged up, and you end up just seeing lots of people who don't need to be seen. So the thought is now, okay, you get in touch with us when you need to be seen, which is fine, and it works really well. But there are some people then that will get forgotten about for lots of reasons. So spotting outliers.
Yeah. Yeah, it's a difficult business, but generally speaking, the healthcare is just difficult.
Yeah, but and I think as well, I think I mentioned last time, but doing something really simple like look at the words decrease and increase. So you find the same sentence as seizures, because it's likely they're going to rabbit on about drugs and a drug change. Would be quite a simple way to maybe look at that.
Yep, definitely.
Can we try that now, Wang, and see what happens? Will you think that will work? Like do a search for increase in seizure and see what happens?
Sure. Why not?
Yeah.
Start sharing my screen. Can you guys see it?
Yep.
Yes.
Okay, so
I think we tried something like this already.
Increase in seizure.
You have "and" spelled incorrectly.
Oh.
Is it 30 letters you're using, or is it 200?
I can load 200. Just take a few seconds. Yeah.
Yeah, so when I'm doing this on Chrome, on Windows, that search, that progress bar never comes up. And when I try to search for something, it just says the letters aren't loaded, even though it does say the letters are loaded in the top bar.
Increase in seizure. Yeah, I'll find a Windows machine and test it out. Yeah, so I think most of increase about drug dosage.
Yes.
Drug dosage. Increased risk of having a reoccurrence in the seizures. So this one is this is what we are looking for, right?
Yeah.
Again, dosage.
Can you filter on the distance between the two terms?
Yes.
That's your edge length. Okay.
So that's absolute distance. So this one is, because that's the distance between centroids.
I see.
The edges. Yeah. So those are close and some are pretty far. Although I don't know why this one is really far. It's because it's centroid distance.
Yes.
This must be a really long letter. Yeah.
Huh.
We look at the shorter ones then. So top part, letter 182. Or 113, Yeah, I think this is where NLP can help a bit, because you'll be able to say increase and seizure in the same sentence.
Because there's one element in my approach that's missing, is the entity and the category. In your exact it outputs what category of attributes that is. For example, the increase belongs to epilepsy, that kind of relationships.
Yeah, that's really hard to do in itself, to attribute a word to an entity. But I think if you do something like, just split it up into sentences, if you could confine it to the same sentence. Are you using Python at all behind this, Henry?
No.
Okay. But this library is out
there. I know what we are talking about, confining it to one sentence. Yeah, that's possible, yeah.
Because that's actually what we do with our rule-based stuff, is combine everything to like the same sentence. And
but the tricky part is here is I split the sentences into different lines. That might interrupt that workflow a bit. Because originally, for example, line 48 and line 49, they might belong to the same line.
The same
but I
sentence.
split it to create this letter space.
I think sentence trumps lines because they could do a full stop and we're done with that topic now and moving on. You know.
Okay. So punctuation based. Yeah.
Yeah. So I think that would help a bit.
Yeah. That's definitely doable. Yeah.
I mean, you've got a letter there.
I think the sentence space. 1, 2, yeah.
Are those centroids, sorry, in the thumbnail views?
This
yes.
one?
Yeah. The absolute.
The purple one is the increase centroid.
Yeah.
The greenish one is seizure. So basically, it's the mean position x and y of all instances.
Yeah.
And then there are some small gray dots that are showing the actual instances in the thumbnail view as context.
I see, yeah.
Yeah.
Yeah. So I don't know whether in the thumbnail view at all it's possible. For a start, if you hover over the thumbnail view, if it explodes up, so it becomes bigger. And I don't know whether in there, it'd be really helpful, I think, if you could visualize the sentence boundaries in the thumbnail view, because then you could quickly hover over and go, oh, that's the same sentence, or, you know, 3 sentences away, or something like that.
So a lot of good features for the next version.
That's the thing. You show this to us, and we'll give you 100 suggestions.
Yeah, no, so very, you know, so to be able to click and the letter comes up, I like that. I like that little touch when you reorder the matrix. You see the lines switching around. I really like that. That's really nice.
This one, animation.
Oh yeah, I like that.
How did you do that?
That's really swish.
Simple.
I think it could be also useful to have, you know, in the chain view could be adopted to incorporate just generic terms instead of drugs. So, for example, just the word seizure or increase added to the drug chain view, and then that would make the drug chain view a little bit more flexible.
I think from the last feedback, Arron mentioned something about adding side effects into the chain view.
Yeah, well, that's the thing. You could have on the left drugs, and then on the top common side effects with an anti-epileptic drugs. And then you'd have a nice, you know.
Yeah.
And just remind me, when you align things up there now, you're just aligning the occurrence of that drug there, that blue drug, yeah?
Yes.
All drugs.
Align every letter by the drug you clicked on. So the first occurrence of that drug will be aligned.
I see.
So for instance, we clicked on letter 60, but it's not the first. We click on the sodium valproate, but it might not be the first occurrence in the letter. But we set it as a base drug. Then we align the rest of letters by this drug. So the first occurrence of sodium valproate in each letter will be aligned.
Okay. Yeah, so this is interesting. Isn't it? Something we haven't really thought about. So that is putting kind of where in the letter the term occurs as being an important feature.
Yeah.
So it can be, and it might be a misleading thing as well, potentially. That is an interesting point. It's something, that we
for
never really...
instance, this is something really interesting. Somehow there are only 3 males. Oh no, it's a line that's shifted below where it should be. Yeah, it's fine. Yeah. Still more female than male.
Oh, right, okay, okay.
Yeah, I think we wrote that in our case studies. We always find more female than male somehow.
Yeah, it shouldn't really be the case that,
Yes, it's the 200 letters.
Yeah, I think roughly epilepsy affects 50-50. More men, women turn up more often or have more contact, because men are less keen on... Yeah, maybe. So you can group that drug chain though then, that was quite interesting.
Yeah, it's only by gender. There's a gap here.
By gender.
Because we designed this feature for pregnancy and sodium valproate.
Yeah. If you had like 3 groups, like young, middle-aged, and old.
Yeah, that's possible. Yeah.
Yeah. Just have like patches or something.
Yeah.
Okay.
Yeah, we can also sort the drug chain view just by number of drugs. That was one of the ideas, just to find outliers. Like if sometimes we're finding letters with quite a lot of drugs in them.
Yeah, this one.
And that might be worth having a look at.
Might not be the most number of drugs, but most occurrence of drug names.
Yeah, that does depend a little bit on who's writing the letter. And some people will put the drug at the top. They'll write about their discussion with the patient, and then they'll recap everything at the bottom.
Yeah, this one is, in the past, he has tried all the drugs. Would you consider this one as one extreme case where the patient has tried so many drugs?
Well, about 30% of people with epilepsy have drug-resistant epilepsy, and that's defined as trying at least 2 drugs and still having seizures. And of course, we'd see the population would be skewed towards that end. If someone's really well, then we see less of them. So within a specialised epilepsy service, we'd see more of the more complicated people. So it's not unusual. There's like an exponential decay in the success of drugs after the first or second one, So maybe 70% of people will be seizure-free on the first or second drug they try. But then, only an extra 10% will be seizure-free on the third drug, and so on. It decays then. And, it's a bit of patient preference. Some people are fed up and say, okay, I'll just live with the seizures. I don't want to keep on trying different drugs. And some people will really want to try lots of drugs.
Any questions, Bob?
No, I don't think so. I sent a few edits to the paper, Henry.
Yeah, I saw that.
It's really minimal. I think I don't know whether the discussion needs expanding on. I mean, obviously, me knowing can write up the strengths and possibly limitations of the tool based on what we've seen, because that's not really in the conclusion discussions at the moment.
Yeah.
I especially can just suggestions on how we can include some more NLP in there.
Sure.
I know in short would be able to say, in clinical practice what the strengths and weaknesses would be. So yeah, we can add that. But other than that, it looks good.
It does look good. The size is about right as well, isn't it? You can see all the drugs there across the top and the sides, which is perfect.
I think if you can fix the was it the Netify or Net whatever it is app. I think playing about with it, you get more ideas about how it could be used.
Yeah.
I'll try to get it fixed. It looks like a platform thing, not something I can fix, but I'll try to switch to another service and see how it works.
Yeah. And if you're happy for us to do it in our next group meeting, we can show pictures. We might get some ideas back to you from that as well. Isn't it? Arron Hill might have, or Beata might have some ideas, because they've looked at loads of letters in developing the gate thing.
We're trying to create a nice demo video that can be shown to like anybody at any time, basically.
The current one is still a work in progress, the one you watched on YouTube.
Yeah, that's right. And then just the thing with a letter as well. I'd be happy to use
blur the letters,
or use a completely synthetic one, which I've got a few of. That's fine.
I will try to blur those text.
Okay.
That's fine.
Great. Okay. Fantastic. No, it's very impressive. Well done.
Great. Okay, I think that's probably enough for today, unless anybody has some more questions or thoughts.
Do you want to talk more about the upcoming grant application?
Which one? I guess we have two.
Yeah.
So, I'm trying to remember what ours is about. The EPSRC issued a call called, I think it's called Transformative Healthcare Technologies. I don't know if you guys pay attention to those EPSRC calls, but yeah, they're looking to, it's broken up into two phases. One's kind of a pilot study phase, and one is then the full study phase. And we submitted an outline bid in October, and I thought we were supposed to get feedback already in November. It could be that the feedback is coming this week, I'm not sure. And then the full bid for the pilot phase of the project is due, I believe, the first week of February. And yeah, we have different research themes in there. They're all around visualization. So it's a visualization, basically, bid. And it's looking at things like developing visible NLP is one of the major themes. Visualizing very large EHR data sets, so millions or billions of EHRs, is one of the themes. What are some of the other themes? I'm trying to remember. But it's all visualization. I think we have a visible deep learning package in there, work package, and yeah, those kinds of themes. But no matter which, the red thread is the data in large data sets. So no matter who you are, which field you're working in, what you're doing, you're always confronted with these large data sets. And the question is how to visualize the large data sets. And yeah, it's all different packages around. I think image analysis is also mentioned in there, like visible algorithms that perform image analysis and those sorts of things. Yeah.
Great.
Yeah, we submitted one as well, but it was purely to scale up the NLP that we were doing in Wales, and there's some hardware in their servers and stuff. And I think the one that Owen wants to put in, as I said, we can collaborate there. We just need to get more coverage really in Wales. So Yeah, I remember it was supposed to be November. Maybe we get feedback. I'll have to check now.
Yeah, I think these days though, some things get delayed. So I wouldn't mind if the deadlines got delayed by a few weeks. Wouldn't bother me.
Yeah.
We'll see. If the feedback is late, the first thing I'll do is write and say, "Can I have an extra week?" Because the feedback came a week late. Can I have an extra week on the deadline? Yeah, we'll see.
Great. Okay. But yeah, I'll get back to you with a couple of paragraphs and anything on the paper in the next few days.
Perfect.
Sure.
Perfect. And
I'll send you some more info on the grant, and I've put something a bit more further together, really.
Mm-hmm.
And yeah, we're still iterating on the paper as well, so you'll see some more iterations. Nothing major, and some more iterations on the video as well.
Yeah. Okay.
Good.
Thank you very much, Owen and Arron.
It's been great.
Cheers.
Appreciate
Bye.
it.
Bye now.
Bye.
Bye.